Common Core Algebra II notes. Today's lesson 11.5, sine and cosine of the unit circle, day 2. So recall the following definitions of the sine and cosine functions. If theta is an angle drawn in standard position whose terminal ray passes through the point xy. So what all that fancy stuff means is that if you have a circle, all right, in standard position means that one ray is going to be basically on the x-axis, and the other ray passes through a point, whatever that point happens to be on our unit circle, x comma y, then the sine is going to be the y value, and the cosine is the x value. Again, I told you how I remember that, is that I kind of remember it's in alphabetical order, cosine, comma, sine. All right? So moving on to exercise 2, given the function f of x equals 6 sine x, which of the following is the value of f of 60? So remember what this means. Function notation means f of 60 is going to substitute in for the x is equal to 6 sine of 60. Now this you can probably put right into your calculator, because as you can see, 2 of our answers are nice integers here, but 2 are not nice. So understanding what the sine of 60 is sometimes is important. If you put this into your calculator, the sine of 60 actually turns out to be sine of 60 is radical 3 over 2, and you can get that from your triangles that we talked about yesterday. All right, so if you remember from your geometry days, this is 1, 2, the square root of 3. So the sine of 60 is going to be the opposite over the hypotenuse, which is radical 3 over 2. Multiply that by 6, and you simply can do some crossing out here, and I get 3 radical 3 is my answer. So make sure that when you're doing these, you're really thinking carefully. If you're not sure, how I always remember it with the sine function is I always remember that this is the only one I always remember. I remember the sine of 30 is a half, or 0.5. So the rest of them come from there. So if the sine of 30 is a half, then the cosine of 30 has to be radical 3 over 2. Because those are the only 2 possibilities for sine and cosine. And then the opposite, if you think about the sine of 60, the sine of 60 is co-functions with the cosine of 30. So that's going to be radical 3 over 2. And the cosine of 60 is going to be a co-function of sine, which is a half. So those 2 switch. So like I said, if I remember this, the rest of them just kind of fall into place. So I always remember the sine of 30 is a half, and I can always check that on my calculator. And that's how I also make sure I'm in degree mode on my calculator. I do the sine of 30, and it better come up with a half or 0.5, and if it doesn't, then I know I'm in radian mode. All right, and I'll show you a little bit about what I'm talking about with that later on. So exercise 3, if g of alpha equals 4 cosine alpha minus 2 sine alpha, then g of 330 equals, well, I'm just going to get rid of this so I can talk about this for a second. So let's do some substituting. So we have 4 cosine, well, let's start with the proper way. Let's say g of 330 is equal to, degrees by the way, is equal to 4 cosine of 330 degrees minus 2 sine of 330 degrees. Now you can go to your unit circle that we worked on the other day, and you can find out what 330 degrees is. But what you can really do here too is to determine what the reference angle is and what the quadrant is. All right, so what I'm talking about is when you're doing 330, the first thing I determine is what quadrant is 330 in. 330 is in the 4th quadrant, right? If you think about it like this, I know this is 270, I know this is 360, so I know 330 is going to fall in the 4th quadrant. In the 4th quadrant, it's positive, negative. So if we're talking about cosine and sine, I know my cosine is going to be positive and my sine is going to be negative. Now I go to my reference angle. My reference angle is going to be 360 minus 330, which is equal to 30 degrees. So you can just take a minute and just say, well, that means that the sine of 330 is equal to negative sine of 30, and the cosine of 330 is equal to the positive cosine of 30. All right, so when we consider this now, what is the sine of 30 degrees? Well, we just talked about that. The sine of 30 degrees is a half. So that means that the sine of 330 is equal to negative 1/2, and the cosine of 330 is equal to radical 3 over 2. So now that we have our values, we can do our substituting. So 4 times the cosine of 330, which we said was radical 3 over 2, minus 2 times the sine of 330, which we said was negative 1/2. Now you're going to have to make sure you're putting this into a calculator, but it does not want it in decimal form. So you have to make sure you're simplifying it. You can put this in the calculator, but radical 3 has to stay a radical 3. So when you do 4 once, twice, this becomes 2 radical 3, and negative 2 times negative 1/2, I'm right here, is plus 1. So here's our answer right there. I know this part right here is probably the most confusing when we talk about what the reference angles are, but I promise you that as you do these, it will become easier for you. All right? So exercise 4, which of the following is not equal to 0? Well, you can see these are those axis angles, all right, the quadrant angles. So 0 right here, this is 0 if you think about your unit circle, right? This is 0, so this is the point 1 comma 0, and even I have to do this, guys. This is something that doesn't always come easy to everybody. This is negative 1, 0, and this is 0, negative 1. So now, and I'm going to remember that cosine, it's going to be the cosine, comma the sine. So the cosine of 0 is 1. So this equals 1. The cosine of 360 is also the same as the cosine of 0, which is also 1. The sine of 90, remember? Sine of 90 is the second one. So this is equal to 1. And then we get to 270. Aha! So the sine of 270 is equal to negative 1. So that's the only one that's equal to something that is not 1. Moving on to exercise 5. For an angle alpha whose terminal ray lies in the third quadrant. So already I'm starting to think this, right? Third quadrant. Third quadrant is down here. Reminding you, 1, 2, 3, 4. All right? So for an angle alpha whose terminal ray lies in the third quadrant, it is known that the cosine of alpha is negative 0.96. So we know here it's going to be negative, common, and common negative. All right? Which is the value of sine alpha? Okay, so I know, if you look right here, I know that my sine is negative. So I can tell you right away, bam, they go away. So even if you have to guess at this point, you have a better chance of getting it correct. But I'm going to remind you that we can go back to our identity that we worked on the other day. Our identity said cosine squared theta plus sine squared theta is equal to 1. And I might have said sine squared theta plus cosine squared theta is equal to 1, but I'm going to remind you that we have the commutative property for addition, so you can flip-flop those if you need to. So they tell us that the cosine is negative 0.96. So negative 0.96 squared plus, instead of just saying sine, so let's just say x squared is equal to 1. All right, so now let's 0.96 squared is you know what I did here? I just did this. 0.9216 plus x squared is equal to 1. We have to subtract this out. And x squared is equal to 0.0784. So let's slide down a little bit. I'm going to take the square root of both sides, and x is equal to 0.28. Remember, x is equal to our sine of x, which we figured out right here. Okay? Sine squared theta, we changed to x squared. You could have left it as sine squared theta if you wanted to. That would have been fine. But we also know, once again, that it's negative. So negative 0.28 is our answer. That's a handy dandy little thing, that identity. Okay, so now in exercise 6, this is what I'm talking about. A special relationship exists between the trigonometric values of an angle and those of its reference angle. Okay, this is so important to be able to do this. All right, so this says round your answers to the nearest tenth. That means we're using our calculator, which is great. So in each of the following, an angle and its reference angle has been given. But we're going to talk about how to get that reference angle one more time. Using your calculator in degree mode, determine the sine and cosine of both the angle and its reference. Round all answers to the nearest hundredth. So I want to talk quickly. I tell you that the angle here is 110 and the reference angle is 70, because I want to remind you that 110 degrees falls right around here. So again, most of the time we're going to be using this as our basis. So we're either going to use 360 degrees or we're going to use 180 degrees. All right, because if the reference angle falls here in the first quadrant, that is the reference angle. The first quadrant is the reference angle, so there's nothing to do there. So here, if you wanted to find 110, the reference angle, you would do 180 minus 110, which is 70, and that's how we got that reference angle of 70 degrees. Now, the next thing they're asking for us is sine and cosine. So I know the sine of 110 degrees is equal to, remember what we have, this is where in the second quadrant, where the cosine is negative and the sine is positive. I always write that in. So the sine of 110 is going to equal the positive sine of 70, which is my reference angle, and the cosine of 110 is equal to the negative cosine of 70 degrees. Now you put this into your calculator, and this one's going to equal, I'm running out of room here, so sine 110 is equal to and they wanted both of them, right? So sine 110 is 0.9397, and the cosine of 110 is equal to negative 0.3420. Now, if you consider the sine and cosine of your reference angles, all right, so over here, if I said sine of 70 is going to equal 0.9397, and the cosine of 70 is equal to 0.3420. Because remember, that's going to be the positives. Let's try that one more time, and we'll see if we can kind of break it down a little bit easier. So moving on to B. Again, the reason we get 235 is if you think about where 235 falls on our unit circle, it falls down here in the third quadrant. So this is the third quadrant, and again, negative, negative. My x is negative, my y is negative, means my cosine is negative, and my sine is negative. So how do I find that reference angle? I take 235 and I minus 180. And in that case, I get that 55 degrees being my reference angle. Now, 55 degrees. So now let's go back and figure out. Let's put it in our calculator, and I'll show you how to do that tomorrow, making sure it's in degree mode. So we want to do the cosine. Let's do the cosine first because that comes first in our x. So the cosine of 55 degrees turns out to be 0.8 8192, and the sine of 55 degrees is 0.5735. All right, so now if we consider the cosine and the sine of our original angle, which is 235, that's going to be the same as our reference angle, except it's going to be negative. That might have been a little bit easier to understand than the first one. At least I hope it was. So why don't you pause the video just for a minute and see if you can do the same thing for C. Okay, you're going to remind yourself what quadrant you're in. Now, 282, remember this is 270 down here. So 282 falls somewhere in here in our fourth quadrant. The fourth quadrant, x is positive and y is negative. And again, how we found our reference angle now this time is we're going to subtract it from our x-axis on this side, which is 360. So 360 minus 282 is 78, and that's where this comes from. So we put in our calculator and we do sine 78 and cosine 78. Let's put equal signs here. The sine of 78 is 0.9781, and the cosine is 0.2079. So now going back to the question at hand, which is what is the sine of 282, and what is the cosine of 282? We know the sine is the y value, so that's negative 0.9781. And the cosine is positive, so that's going to be the same value, 2079. Okay. Write down what you need to, and we have one more exercise to get through. So clearly, the absolute value of the sine and cosine are the same for an angle and its reference. We can also use reference angles, and I apologize, there's a typo right here. Use reference angles to produce sine and cosine values for angles in the other three quadrants, just like we did in the last exercise. So they're telling us here that the cosine of 30 is radical 3 over 2, and the sine of 30 is 1/2. This is the one I keep telling you. I always remember this one, and the other ones fall into place. So the cosine of 150, so the first thing we have to determine is what the reference angle is. So I always do this. I do a little diagram here. 150 falls between 90, which is here, and 180, which is here, which falls in here somewhere. So I know to find the reference angle, I'm going to do 180, take away 150, so my reference angle is 30. But I'm in the second quadrant. And in my second quadrant, my x is negative, my y is positive, which means my cosine is negative, my sine is positive. So if they're asking us for the cosine, we know the cosine of 150 is equal to the negative cosine of 30. And we know the cosine of 30 is radical 3 over 2, so it's negative radical 3 over 2. All right, moving on to B. Let's do this one more time, and then I'm going to set you free to do the rest. So, sine 150. Once again, 150, we don't have to talk about what quadrant it's in because we talked about it right here in exercise A. So, I know my reference angle is 30 degrees again. Now I know my sine of 150 is equal to the positive sine of 30. Because in the second quadrant, my sine is positive. The sine of 30 is 1/2, so my sine of 150 is going to be 1/2. Okay, maybe we'll do one more. Let's do cosine 210. So, cosine 210, we're going to come over here. 210 falls, here's 180, here's 270. So 210 is going to fall down here in my third quadrant, which are both negative. All right, my reference angle is 210 minus 180, which is, oh, what a surprise, 30. All right, so 30 degrees. And so we know that the cosine of 210 is the x value, so it's going to be the negative cosine of my reference angle, which is 30, which is negative radical 3 over 2. Hopefully these are getting a little bit easier. So why don't you try the next three, and we'll come back and discuss it. Well, if you remember from exercise C, that 210, the reference angle was 30 degrees, and I was negative in both my cosine and my sine. So my sine of 210 is equal to the negative sine of 30, which is equal to negative 1/2. Now we have a new angle. 330 falls here in the fourth quadrant. I know in my fourth quadrant I'm positive negative. Cosine is positive, sine is negative. So I know that the cosine of 330 is equal to, oh, and by the way, our reference angle, surprisingly enough, is still going to be 30 degrees. So it's going to equal, cosine is positive, and if you put the plus sign in, you can. Positive cosine of 30 degrees. So the cosine of 30 degrees is radical 3 over 2. So it's positive radical 3 over 2. And our last one, same thing. We have our reference of 30. We have positive, negative. So in this case, our sine of 330 is equal to the negative, because remember cosine is the y value, negative sine of 30, which is equal to negative 1/2. So hopefully you're recognizing that there's two things that you need in order to find the sine and the cosine of pretty much any angle from 0 to 360, and then so if you consider the coterminal angles. And you just need to find out what the reference angle is and then what the sine is in that quadrant. These are exact values, 30, 60, 90, and our quadrant angles are all exact values. I'm sorry, 30, 60, 45, and any one of those reference angles. But sometimes, just like in one of the other exercises, they'll ask you to round it to the nearest tenth, because you can use your calculator to determine these as well. So when you look at radical 3 over 2, most people know if you look in your calculator, that's 1.732. So certain numbers you will start to understand what they look like in your calculator. So until next time, make good choices and keep thinking.